So, that's how you can. The boys made fun of me today when I said that dark energy and dark matter are the same. Well, making fun on others isn't cool, but yes, they're wrong. What do you mean? They are the same thing. Like the relationship between the weak nuclear force and the strong nuclear force, or the photon and atoms, the dark energy and dark matter. Bro, that's not true at all. There's a huge difference between the dark energy and dark matter. What's the difference between the dark energy and dark matter? Well, we will talk about it now. In this room where I'm sitting, there's an ordinary matter everywhere, like this table and this astronaut, or me. But there are things that the natural eye cannot see. Like in this empty space of room. What is it? Maybe there's oxygen molecule, or electromagnetic waves, or different shapes of particles, and there may be some radiation. But are there things in this empty space in my room that we cannot see it in any way? Well, there is. In fact, not only in my room, in the streets, and the city, and the whole planet, and all over the universe. Let's talk about the first one, which is called the dark matter. The dark matter, it's an invisible material, and according to CERN organization, it makes up 27% of the universe, which compared to the ordinary matter that makes up 5% of the universe, it is many times greater than any ordinary matter. If you want to know about the dark matter, you must be reminded first that the dark matter isn't part of the particles group. Basically, dark matter does not interact with any ordinary particle. As you know, natural materials interact all the time by giving and receiving electromagnetic waves, ionization processes, weak nuclear energy, nuclear fusion, and other reactions. But dark matter don't. It actually passes through the object and the matter, and no ordinary matter can affect on the nature of the dark matter. So we cannot see it because the photon particle doesn't interact with it at all. How do we know if dark matter doesn't interact with anything? Well, where there's dark matter mostly, it bends the light and changes its way. This means dark matter interacts with only one thing, and that thing is gravity. Dark matter has a direct relationship and interaction with gravity. Wait a minute. If we can see it anyway, how do we know it exists? Actually, the discovery of dark matter is a very interesting story, and I can tell it without you interrupting me. Alright, chill. No need to be heady. In 1932, the scientist Fritz Zwicky noticed that... the Z is silent. Okay. In 1932, the scientist Fritz Zwicky, while he was studying some clusters using his observatory telescope, he realized that something strange happening in the cluster. And if you don't know what clusters are, there are a group of galaxies that move and revolve around each other in a dancing manner without merging with each other. Not only did Fritz Zwicky notice that these clusters are moving rapidly around each other, but that the galaxies themselves rotate rapidly as well, which is physically impossible. Not impossible, but it just doesn't make any sense. The problem is, these galaxies don't have enough gravitational pull to create such as fast and ordered motion. To put it simpler, the amount of gravity that these galaxies need to create this motion is that big, but the amount that the clusters actually have is that much. The amount that the galaxies need is 6 times more than the actual number. Plus, if galaxies rotate at this speed, how can the stars remain in their orbit and not scattering? At first, scientists put forward some hypotheses about this weird case. What causes this strange event in galaxies and clusters? Is it caused by a group of planets, stars, black holes, neutron stars, and other type of cosmic bodies? No, the mass is still not enough to hold into these types of cosmic bodies. You need billions or trillions of tons of mass. Is it caused by black holes? We don't think so, because black holes are supermassive objects and have a specific position and point, and they orbit around the galaxy. Plus, we detect them and we take image from them. But dark matter seems to be everywhere. From here, the idea of dark matter had been created, and it changed everything. So, as a result, 1. The dark matter is everywhere and a lot. 2. It can pass through the object without changing it. 3. It cannot be seen because it does not interact with ordinary particles or any nuclear fusion. Some scientists believe that after the Big Bang and the formation of the first hydrogen and helium atoms in the universe, if the dark matter intervened in the atomic fusion process that took place during that period, the structure of the atoms and the materials in the universe would have been different and not in the same shape that they are on it currently. This is what dark matter is. Well, guess I'm done here. Hey, what? What are you going? Didn't you finish? Is there more? What about the dark energy? What have you been talking about all this time? I was talking about the dark matter. Are you even listening? Looks like we will have a long day. As we know, the world began to expand continuously since the Big Bang. If the universe used to expand for a while, then it is natural for it to slow down over time. So, scientists studied the light of the stars more accurate, so they can for the last time measure the speed of expansion of the universe. If you don't know what light has to do with all expansion thing, you must know that if there's an object such as a galaxy or a star moving away from you, its light will appear as red. If it's coming toward you, the light will transmit it to you in the form of blue. And this is how Edwin Hubble discovered that the universe is expanding, when he noticed that the change in the color of the stars and galaxies to red. Everything was normal until in the 90s, the scientists observed some supernova explosions, and they noticed that the light that transmitted from them was strange compared with the distance between these two supernovas. They noticed something very strange. The distance that light between two supernovas moves, it's getting more farther, and they are getting away from each other. If the universe was slowing down, these two supernovas should be close to each other, or at least not getting farther from each other in time. At that moment, scientists discovered something broke the laws of the whole cosmic constant. The universe is not only expanding, but it's accelerating too. Scientists tried to calculate the expansion rate, and it was a gigantic number. In order to show you that how much the universe was expanding so fast, we will put it in this way. Stars are forming, galaxies are merging together, until a day comes, and then... According to the known laws of physics and study of mass and pressure, the mass cannot produce such as this pressure to expand the universe in this velocity. You know why? Because there must be a lot of pressure on both sides, which we will talk about it in the future. Is the reason for this super expansion caused by the energy generated from the creation and annihilation of virtual particles to each other in empty space? No. Was it caused by the supernova explosion waves? Certainly not. It might be huge and supernatural to you, but for the universe it's like there's an energy causing this acceleration, which is something else, something great, something different, something special, something. Okay, we get it. What is that thing? The scientists call this energy the dark energy. No, but seriously, dark energy was the best explanation for this acceleration and the expansion, and some scientific articles support it, which you can find the links of the articles in the description if you want to check the sources. Dark energy makes up 68% of the universe, and it may increasing at this moment while I'm speaking to you. Normally, if the gravity of galaxies and cosmic bodies were more, the universe will shrink and cause a giant explosion due to the combined mass. However, due to the expansion caused by dark energy and space, these cosmic bodies do not meet, and as a result the universe will expand forever and gravity will not be able to defeat this expansion. Since the dark matter is related directly to the gravity, so the dark energy and dark matter are like opposite charges. This picture describes the process in a simple way. You can see that when the universe size increases, the total dark energy in the universe increases as well, and the gravitational pressure that occurs in the universe due to dark matter decreases. We can see the universe change in time, and this shows that the level of dark energy in the universe increasing, and it predicts what will happen in the future. Remember one thing: more dark energy, more space. More space, more dark energy. More dark energy, more... Okay, I think you get it. Wait a minute, that's exactly what I said. You said what? I said that dark matter and dark energy are like anti-energies, like the opposite charges. Yeah, but you consider them to be from the same source and they are related to each other, and this is wrong. It's like saying that without Neptune there will be no Venus. Oh damn. What is dark energy anyway? Most say that dark energy is something like waves or rays that are widely present in a region, but on a cosmic scale. If it is, then we must search and find out its source and the reason for its formation. But perhaps dark energy is only anti-gravitational energy, as it moves against the gravitational system of cosmic bodies. Perhaps dark energy is not a thing, but maybe it's the property of empty space. Perhaps what causes the expansion or acceleration and expansion is the empty space itself, and only increases in size because it's space in the first place. Space-time may be like a cube or a square that bends, but what if it was just a one square or one cube? If it is, then it is natural for this empty shape of space to expand and increases in size. Will we be able someday to take images or at least see how the dark energy look like? Is dark energy really just the property of empty space, or is it really a type of energy? Who knows? Maybe someday we will be able to know that, or maybe you're going to be the one who will find out. Whew. We try to explain these big differences in the most summarized way. Next time when someone asks you what's the difference between dark energy and dark matter, give him these answers. Or you can simply just let him watch this video. Okay, any questions? I have a question. You mentioned previously the relationship between the mass and pressure. Can you talk about that more? Well, and if there's a connection, can you explain the mechanism of mass more broadly? Well, we will leave these topics for another video. Until that day, do not stop wondering and be curious.